So here we go with the mods 20 and 21 group test. Let's jump right into it. The prices of sweaters at a department store are normally distributed with a mean of $40 and a standard deviation of $3. That means if it's normally distributed, if I look at my notes page, that means it's going to follow this pattern. And from before, we should know that this is 34%, 34%, 13.5%, 13.5%. This one is 2.35%, 2.35%, and 0.15%, and 0.15%. I'm going to change to pencil just in case I need to use this more than once. So normally distributed, make sure I'm all on the screen here, and let's see, the mean is $40, so that's going to go in here, and the standard deviation is 3. So if I add 3, that makes this 43, 46, 49. And if I subtract 3, I have 37, 34, and 31. Now part A says what percent of the prices are between $37 and $49. So if I look at 37 as one boundary and 49 as the other, I need to add 34 plus 34 plus 13.5 plus 2.35. So 34 plus 34 plus 13.5 plus 2.35. There should not be any rounding issues on this. You should get exactly 83.85%. Okay, I do not accept 84% because you need to add the exact numbers that are right here. Okay, what is the probability that you choose a sweater that costs more than $34? So, not using that anymore, but more than $34. Here's 34. You would add up all these numbers. Or, as a shortcut, you could take 100% and subtract these two. Either way works. So let's see, 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15. That gives me 97.5%. Again, you shouldn't get about that, you should get exactly that. Part C, what is the probability that you chose a sweater that costs more than $45? Well, 45 is no longer on my chart. As soon as I hit something that's no longer on my chart, it's no longer one of these numbers, I have to use a z-score. So going back to using a z-score, I'm going to say 45, which is my number that I'm interested in, minus the mean, which is $40, divided by the standard deviation, which is 3. 45 minus 40 is 5, divided by 3 is, now I need 2 digits past the decimal in order to use my z-score table. So I'm going to call this 1.67, and I'm going to go to my z-score table. So on my z-score table, 1.6, here's 1.6, 0, 1, 2, 3, 4, 5, 6, 7. So there's my 0.7. I get 0.9525. 0.9525. So remember, from the chart, that tells me the probability less than 0.9525. So, or I'm sorry, not 0.9525. They're saying that 0.9525, or in other words, 95.25% of the sweaters cost less than $45. But I don't want to know less than, I want to know more than. So I'm going to take 100% and I'm going to subtract 95.25 because I want more than. So let's see, 100 minus 95.25 gives me 4.75%. Part D, what is the probability that you chose a sweater that costs less than $45? Well, that is the same number, so it has the same z-score, and that is the value from the chart, so it would be your 95.25%. And then finally, part E, what is the probability that you chose a sweater that costs between $35 and $45? Well, I take the less than $35 and the less than $45, and I'm going to subtract them off the chart. Now, less than $45, I already got. That was the answer to part D. So that's 95.25%. 35, I don't know. Is it one of my numbers? It's not one of my numbers, so I need to do a z-score for 35 also. So 35 minus 40 divided by 3. 35 minus 40 divided by 3 gives me negative 1.67. Again, going to my chart. On the negative side, negative 1.67 is 0.0475 or 4.75% is less than 35. So what am I going to do? I'm going to take this 95.25% and I'm going to subtract 4.75%. And let's see what that leaves me with. 95.25 minus 4.75, and that leaves me with 90.5%. Now that's 18 points. That's a big, big chunk of points for your test. If you skip number 1 entirely, you're already down at a B minus, so not a good idea to skip. Also, those percentages, I do not permit rounding off on those. There's no place where you need to round off on those. You should have them exactly as I have them. Okay? Number 2, the mean length of songs played on the radio station is 3.1 minutes with a standard deviation of 1.2 minutes. The station chooses a random sample of 20 songs. Well, I know that when they tell me a random sample, I know that that is my N value when I'm doing anything with the sampling means and such. Find the mean of the sampling distribution of the sample mean. Now, from our notes, sampling means the mean of the sample means is equal to the mean of the whole population. So, the mean of the sample means, remember X bar means mean, is equal to the mean of the whole population, and the mean of the whole population is 3.1. So again, no rounding necessary, 3.1, straight from the problem. Okay, had to relocate to get out of the sun a little bit there. Now it asks for the standard deviation of the sampling distribution of the sample means. Rounded to the nearest thousandth, which means I'm going to get a decimal. So, of the sample means, which is over here, instead of the sampling proportions, to find the standard deviation, I take the standard deviation of the whole population and divide it by the square root of n. So, the standard deviation of the whole population is 1.2. So I'm finding the standard deviation of the means. It's equal to 1.2 over the square root of n. And I said at the beginning, n is the sample size, which is 20 songs in this case. So 1.2, let's see, 1.2 divided by the square root of 20 is 0.26, they say the nearest thousandth. That's 3 digits. There's an 8. After that comes a 3, which means that's going to stay an 8. So 0.268 would be my answer right there. What interval captures 95% of the means for random samples of 20 songs? Now, 95% is an important number. If you remember from here, these two together make up 68% of the data. These two together make up 95% of the data, and these ones make up 99.7% of the data. So 95 is this middle one. 95 is my mean minus 2 standard deviations, all the way up to my mean plus 2 standard deviations. So let's take the mean, which is 3.1, and we are going to do, if I were to do a bell curve, I need the mean in the middle, and I need to know what 2 lines out is. I need to know this one, and I need to know 2 lines out on this one. So I need to know those 2 values. So 3.1 minus my standard deviation, which is 2.268, 3.1 minus 0.268 gives me my value for this line, but I need to subtract it one more time to get that second line. So that's 2.564. And then to get the other one, I'm going to add it. So 3.1 plus 0.268 gives me that first line right there, plus another 0.268 gives me that second line, which is 3.636. So between what two numbers? Always list the smallest one first. So 2.564 and 3.636 would be my two numbers. Okay. So down here now we're talking about what is the probability that a sample mean has a song length between these two values. Now I could check and see if I were to make this 2.5, not exactly, let's see, 3.1. If I were to do just the original bell curve, doesn't say it's normally distributed, but we should be okay. Let's see, 3.1 minus 1.2 minus 1.2. Nope, doesn't give me those values, so I'm going to have to find z-scores. So I'm going to start off with the z-score of 2.5, and whenever it says between, I need to get a value of one, a value of the other, and subtract them, just like I did right up here on 1e. So z-score for 2.5 would be 2.5 minus the mean, which is 3.1, divided by the standard deviation, which is 0.268. When I divide those on my calculator, 2.5 minus 3.1 divided by 0.268, I get negative 2.24 is what that's going to round off to. Negative 2.24. That's what I'm going to have to go get from my z-chart. So on my z-chart, negative 2.24, negative 2.201234 is 1.25%. 1.25%. Now I'm going to do the same thing for 3.6 minutes. 3.6 minus the mean, which is 3.1, over 0.268, which is our sample mean standard deviation. When I divide those, 3.6 minus 3.1 divided by 0.268 is 1.87. Again, going to my z-score table, 1.87, 96.93%. So again, take the bigger one, subtract the smaller one. 96.93% minus 1.25%. 96.93% minus 1.25 gives me 95.68%. So my answer to letter D is 95.68%. So again, all of number 2 was about, oops, that's not what you need. All of number 2 dealt with sampling means. So these formulas on this side. Okay? All right, moving on to question number 3. Explain the meaning of a z-score of -3. When we look at our bell curve, this would be a z of -1, z of -2, z of -3. Z of +1, +2, and +3. So a z-score of -3 means 3 standard deviations below the mean. Because in order to get there, you're subtracting one standard deviation, subtracting another standard deviation, and subtracting another one. You are subtracting 3 standard deviations. So a z-score of +3, sorry, I keep going off the screen there, a z-score of +3 would be 3 standard deviations above the mean. Okay, so that's what we've got going on there. All right, about 72% of all the students at Glenn's high school have a social media account. Glenn chooses a random sample of 50 students, that's my n value, at his high school. Use the formulas to confirm that this distribution is approximately normal. Using the formulas to confirm, that's these guys right there. Remember, we had to show that both of them were less than 10. I'm sorry, greater than or equal to 10. So I need n, which I know is 50. I also need p. And p is our percentage, which is 0.72. So I need to show that NP, so 50 times 0.72 is greater than or equal to 10. Well, 50 times 0.72 is 36, and that is greater than or equal to 10. And I also need to show the other one, which is 50 times 1 minus 0.72 is greater than or equal to 10. 50 times 1 minus 0.72 also has to be greater than or equal to 10. So, my calculator, 50 times 1 minus 0.72 is 14, which is still greater than or equal to 10. So my answer is yes. I do need to see the work for that, so please be showing your work there. Find the mean of the sampling distribution of the sample proportion. Guess what? The mean of the sampling distribution is equal to the mean of the whole thing. So if P up here is 72, then guess what? P down here is also 72%. Find the standard deviation of the sampling distribution of the sample proportions. Again, here's your key that you're talking about the proportion side and not the means side. So find the standard deviation. I take the square root of P, which is 0.72, times 1 minus 0.72, divided by n, and n in this case is 50. So going to my calculator, when I calculate that all out, let's see, 0.72 times 1 minus 0.72 divided by 50, and then the square root of that answer is, it says nearest thousand, so I need 3 digits past. 0, 6, 3, 4 would just stay a 3, so I have 0.063. Now, standard deviation is not a percent. It's the only one that's not. Now, what is the probability that in the random sample more than 58%, zoom out a little bit, there we go, that'll be helpful. What is the probability in the random sample more than 58%? So again, more than, so I'm going to find the z-score and I'm going to subtract from 100 just like usual. So 58 minus, let's change that 58 to a decimal actually, because we don't actually calculate with percents, times 0.72 again, divided by the standard deviation, which we just found is 0.063. 0.58 minus 0.72 divided by 0.063. Negative 2.22. So going to my z-score table, negative 2.22 is right here. That's 1.32%. Now that would be my answer if they were asking for less than 58%. Since they're not asking for less than, they're asking for more than, I have to subtract it from 100%. So 100 minus 1.32 is 98.68%. That's what I get for D, 98.68%. And finally, E, what is the probability that you get between 58 and 88? So again, z-score, z-score, get your values off the table, subtract bigger minus smaller. So between, so I need less than 58% and less than 88%. Now this is a little tricky because this last answer is not less than 58%. That's what was less than 58%. So this is 1.32%. Now for the 88%, I have to find a z-score again. So 0.88 minus 0.72 over 0.063. And when I do that one on my calculator, I get 2.54. It's actually 2.539, but that would round off to 2.54. So going to my z-score table, positive 2.501234, 99.45%. 99.45%. So I'm going to take 99.45% and subtract the 1.32% to get my answer. 99.45 minus 1.32 gives me 98.13%. in my answer box. 98.13%. Okay, that's the hardest work. That first set of problems is the hardest bit of work there. All right, we need to figure out which is the sample, the statistic, the population, or the parameter. The mean grade on the final exam was 81% for the 75 students enrolled in IM3. That gives us a lot of information right there. That gives us our population, and the piece of data that goes with your population is your parameter. Remember, P goes with P, which means that leaves me with a sample and a statistic. This is my sample, and the piece of data that goes with my sample is the statistic. Okay? All right, coming down here, this histogram shows the ages of people in a waiting room. There's nobody here. There are 2 people that are ages 5 to 9. There are 4 people that are ages 10 to 14. There are 5 people ages 15 to 19, 3 people ages 20 to 24, and 2 people ages 25 to 29. How many people under 20? So that would be these 3 boxes. So 2 plus 4 plus 5 is 11. Some of you typed in 11 people. Don't type in the word people, just type in 11. How many people ages 15 and over? So that would be this bar and these 2. So 5 plus 3 plus 2 is 10. How many people are included in the histogram? 2 plus 4 plus 5 plus 3 plus 2. There are 16 people in that waiting room. Okay. All right, turning the paper over. Number 7, there were several different answers. Categorical data means I don't want the answer to be a number. So you could ask a question like, what is your favorite color? What is your favorite flavor of ice cream? Something where their answer would be a word, not a number. Word answer. One question you could ask if you wanted numerical data. You want something that gives you a number answer. So you could ask about their height, age, etc. Now I do want you to write a full sentence, write it properly there. I'm just abbreviating there. So again, number answer, word answer. All right, the data listed is the number of cousins each student in the 3rd period class has. Make a line plot of the data. Looking at the line plot, the smallest number I have is 0. So I'm just going to start counting. 0, 1, 2, 3, 4, 5, 6, 7. And our line is perfectly long enough. And I'm going to start making X's. There's a 4. I've got 3 2s in a row, 3 3s in a row, a 1, a 2, a 1, a 5, a 3, a 0, 1, 3, 2, 0, 1, and a 7. So there's my line plot or my dot plot. This one has a definite skew. If you see the pattern, it's kind of mounded over here, and we would say that the tail is over here. If the tail is on the right, that means it's skewed to the right. If the tail is on the left, that means it's skewed to the left. Okay. All right, 2 box plots. Which set has the larger IQR? From a box plot, the IQR is how wide your box is. So if this one goes from 7 to 13, what's that range? 13 minus 7 is 6. This one right here goes from 6 to 13. So that one has an IQR of 7. So which data has the larger IQR? B, because it has the wider box. Estimate an interval for data set A that represents 75% of the data. Remember, each part is 25%. 25%, another 25%, and another 25%. So you could either say from 4 up to, it would have to be 3 parts. So 1, 2, 3, and ending at 13. Or you could say starting at 7, 1, 2, 3 parts, ending at 16. Either of those are possible answers. Okay? And our last question, identify each scenario with the appropriate sampling method. Every student's name in the class is put into a bin. One student name is drawn from that bin to win a prize. That is simple random. Anytime you hear about names being put in a hat and drawn, everyone has an equally likely chance. It's always simple random. You want to try to predict who the new ASB president will be. You ask all your friends and choose their favorite candidate. If you're asking all your friends, that's convenience. Convenience is the easiest people to get a hold of. Okay? Okay, the teacher asks for volunteers. Anytime you have volunteers, you have self-selected. Okay? You want to know if people in your class have their driver's license. You ask every fourth person. Every time it's like every other person, every third person, every fourth person. There is a system to it. That makes it systematic. And finally, you want to know the average age of 9th graders. Since all 9th graders are enrolled in English, you select 5 classes of English 9. That by itself is cluster. However, it would only be cluster sampling if you picked the 5 classes and asked everyone in those classes. Since you're not asking everyone in those 5 classes, you are only asking 10 people in each class. That now makes it stratified. So cluster would be if you had it broken into groups and you took entire groups. If you're only taking parts of those groups, that makes it stratified. Okay? Good luck and happy studying.